Hey guys, we're gonna do a couple different videos. The first one is series circuit, 12 volts, one load. Okay, one load, 2 ohms maybe. So voltage and resistance is available. So voltage divided by resistance is 6 amps. Okay, this is one example. Here's my next example. 12 volts. Now I have two loads. Okay, this is 2 ohms. This is 2 ohms. Okay, in a series circuit, you're going to add the individual resistors or resistances to get your total resistance. So that's 2 plus 2. So RT is 4. So RT is equal to 4. Okay, amperage total, AT, is equal to voltage divided by resistance, 3 amps. Okay, 3 amps. Let me clean that up a little bit. 3 amps. Okay, so now we did a series circuit with one load. We've done a series circuit with 2 loads. Now we're going to do a series circuit with 3 loads, but we're going to add voltage drops. Okay, so again, 2 ohms, 2 ohms, maybe 1 ohm. Okay, whatever the values are. This is just to understand what's happening in the circuit. Again, my resistance total is going to be 2 plus 2 plus 1. So 2, 4, 5 equals 5 ohms. Okay, my amperage total is going to be voltage divided by resistance. So 12 divided by 5, 12 divided by 5 is 2.4. 2.4 ohms. Okay, 2.4 ohms. Now we have amperage through the circuit. Now I want to do voltage drops. Sorry. So I have 2.4. So to figure out voltage drops for each one, I'm going to get my amperage and multiply it times each individual resistor. Okay, so 2.4 times 2. 2.4 times 2, 4.8. Okay, so this first one is 4.8 volts. Okay, the next one is also going to be 4.8. 4.8 volts. 2.4 times 2, 4.8. The last one is 2.4 times 1. Okay, that's 2.4 volts. In a series circuit, the sum of all your voltage drops must equal source voltage. 4.8 plus 4.8, 9.6 plus 2.4, 12 volts. Okay, so this is a series circuit. These are 3 different examples. They included voltage drop here. They included total amperage, total resistance. Notice what happened. My resistance was less, my amperage was more. As my resistance increased, my amperage started to decrease. And as it increased further, it decreased more. This should be not a resistance value, this should be an amperage. Sorry, I just caught that right now. Okay, so remember, as resistance goes up, my total resistance goes up, 5, 4, and 2. My amperage goes down, 6, 3, and 2.4. These are the rules for a series circuit. Okay, I'm going to publish this video so you guys can review them if needed. I am going to add one thing that's new, which is Watt's law. Okay, Watt's law is going to tell us the power that each one's going to use. Okay, so that's going to be, Watt's law is different. Watt's law is voltage times amperage equals watts. Okay, I'll just add it here because I know we just learned about it in some classes today. So that means 2.4 times 4.8. 2.4 times 4.8 equals 11.52. 52 watts. So it's also 11.52 watts. And the last one is 2.4 times 2.4. 2.4 amps times 2.4 volts equals 5.76 watts. What we learned was that the more wattage, more power, the brighter the bulb was going to be. These 2 bulbs are going to be equally as bright. This one's going to be about half its brightness. This is a series circuit formulas. Okay, hopefully this helps you guys. You guys can watch it over and over. If not, please feel free to ask me more questions.